All right, this is the last video for Unit 7 for your review for the final and our most recent material. So we have a set of normally distributed data with a mean of 105 and standard deviation of 11. So normally distributed data, like operates in a certain way or behaves in a certain way. You can make a lot of estimations that are pretty good. We need to know the mean and the standard deviation because remember, those are the two values that will determine a normal distribution. So the mean is 105. So I'm going to put that in the middle of the curve. We're going to label the normal curve. So here's our mean. It's 105. And then with a standard deviation of 11, what I'm going to do then is label these using the standard deviation. So 105 plus 11 is 116. And then add 11 to that, you get 127. Plus 11 one more time, you get 138. And so this is above the mean, then below the mean. We're going to take away 11 each time. So 105 minus 11 is 94. Minus 11 is 83, and then 72. Okay, so once that's set up, then you can start answering questions about how much data is in each space. So first, between what two standard deviations, or between what values would you expect to find 68% of the data? So 68% of the data followed by 95 and then 99.7. So one thing we learned called the empirical rule is that 68% of the data that's normally distributed will fall within one standard deviation of the mean. So that means for this problem between 94 and 116. And then for 95% of the data, so we know that 95% of the data will be within two standard deviations of the mean. So the values are 83 to 127. And then finally, where would we expect to find 99.7% of the data? And that's going to be within three standard deviations of the mean. So 72 to 138. Okay, so the next question, approximately what percent of the data is less than 94? So there's so many ways you can answer all of these, but here's 94. We have to find the percent of data on this side of it, okay? So I like to use the fact that I know half the data is on each side of the mean. And so I know like all of, oh, my camera froze. Hold on one second. My document camera freezes sometimes. So there we go. Okay, so I know like 50% of the data is on both sides of the mean. And so for less than 94, this space right here is half of that whole space, which is 68. So half of 68 is 34. So together, these will make up 50%. So I'm going to calculate by doing 50 minus 34, so 16%. All right, and then approximately what percent is less than 127? So 127, less than 127. So here's 127. And so we're talking about like all of this, right? All the way down to the very end. So this much of it, like from the mean down, is 50%. Okay, so I'm going to say, well, 50% for left of the mean. And then for from the mean to 127, so from here all the way to the 127, that's half of that 95%. So 95 divided by 2 is 47.5. So I'm going to add that to 50. So plus 47.5, 97.5%. Okay, and then the last question in this row, approximately what percent of data is between 83 and 116? Okay, so I'm actually going to, because this is starting to get really messy, I'm going to make like just a simple little curve for that. So from 83 to 116. So here's our mean. So 83 is 2 standard deviations below the mean, right? So I'm just going to write 1, 2 to there. And then 116 is 1 standard deviation above the mean. So just 1. Okay. So I'm going to look at it as 2 parts. I know the part on the left is equal to 95 divided by 2. So this space here is equal to 95 divided by 2. And this space here is half of like the 1 standard deviation. So it's equal to 68 divided by 2. All right. Grab my calculator really quick. Just because we've been doing this so much, I know 95 divided by 2 is 47.5. I'm going to add that to 68 divided by 2, which is 34, for a grand total of 81.5%. All right. Okay, the next one is between 94 and 127. And it's kind of like the problem before it, because here's our mean. This time, 94 is 1 standard deviation below the mean. So this is the part that's 34. And 127 is 2 standard deviations above the mean. So 47.5. We just found those 2 values in the problem before. It's just it was 1 to the right and 2 to the left. This is 1 to the left and 2 to the right. But it's going to be the same percent of data because it's showing, it's using spaces that would have the same area. So 81.5% again. Okay, next is more than 110. And now we have, more than 110. So 110 is going to be, find a color, 110 is going to be somewhere in this area here, meaning it's not like on a standard deviation. So this is when we need to use a z-score. And I would expect to get a z-score that's positive but less than 1. And then my final answer, I'm looking for how much is more than this. Okay, so on that side of it. Okay, so first we're going to find the z-score. So that is equal to the data point 110 minus the mean, which is 105, and then divided by the standard deviation of 11. So I know 110 minus 105 is 5. So I'll just type it in. 110 minus 105, get the answer, and then divide it by 11. And following the rules of rounding, round to 2 places. So 0.45 is what we're going to use for a z-score. Okay. So when I look at the table, I'm going to go to the positive side. Here's 0.4, and then 1, 2, 3, 4, 5. So 0.45 has 0.6736. 0.6736. Okay, so when I found this number off the table, it's not giving me what's more than 110, it's giving me what's less than 110. So since the total area under the curve is 1, if I know this much, I can take it away from 1 to get the other side. So 1 minus 0.6736 is 1 minus 0.6736 0.3264. But again, it's asking for a percent, so that's 32, right? 2 decimal places. 32.64%. And if you don't remember how to change from decimal to percent, if you have something in a decimal, you just multiply it by 100, since percents are out of 100, and then it moves the decimal for you. So 32.64%. And then last question, approximately what percent is between 85 and 125? So we're in that predicament again where neither of those are like one of the numbers we use to number this. They're not whole number standard deviations. So 85 would be about here, 125 somewhere over here. We have to figure out what's between them. So I'm going to draw one more little curve to just kind of say, okay, so 85 is somewhere down there, 125 is somewhere up here, our mean's here in the middle. And so we have to figure out the standard deviation for each of those. And that's what a z-score is. So for the 85, the z-score, 85 minus 105 divided by 11. So 85 minus 105, and then divided by 11. Negative 1.82, you round, following the rules of rounding, negative 1.82. And then the other z-score comes from 125. So 125 minus 105 and divided by 11, and that is positive 1.82. Okay. So what we just found is that this point right here is 1.82 standard deviations above the mean, and this one is 1.82 standard deviations below the mean. Okay, so that's what a z-score is. And now we're going to find the areas from the table. So for negative, or let's just say from 1.82, 1.8012. So 1.82.9656. So this one gave me 0.9656. And what that means is that that's the area under the curve to the left of this point, okay? So I only want to know from here to here, so I'm going to use the table to find this value, negative 1.82. Negative 1.8012, 0.0344. So this one was 0.0344. So that means that's this part. And so if I just want to find what's between them, I'm going to subtract them to get rid of this side over here. So 0.9656 minus 0.0344 is 0.9656 minus 0.0344. 0.9312. And again, as a percent, oops, just multiply it by 100, 93.12%. All right, we did it. We made it all the way through the review. I hope you found these videos helpful, and I hope you do awesome on the final. All right, happy studying.